So let's look at another example together. I've used colours here to emphasise the fact that this part of it has got nothing to do with the function you're integrating. This is the thing I'm integrating. What this means is, as I've said already, integrate this function with respect to x. So that's just the notation, the red bit. So what do I do? Well, the first thing I would do is, as I've said, implied already, the constant, which is the 5/2 in front, can come out of the integral. So let me just worry about this bit, which has got the x in it. And then at the end I can tidy up and the 5/2 will come back into play again. I can't integrate this as it stands because it needs to be in that index form, so I need to use the laws of indices and rewrite this. Roots go underneath in the fraction, powers on top. No number means it's a square root, so x to the 3/2 with respect to x. So that's the first thing. Organize this function I'm trying to integrate so I get it to a form where it's easy to try and apply the rule. Now, as soon as I see it, something like this, x raised to some power, it's that asterisk rule that we had in words which says add 1 to the power, there's the power, and divide by the new power. That's all you do. So, to integrate it, as soon as I integrate it, this integral symbol disappears. I'm going to add 1 to the power. 3/2 plus another 2/2 is 5/2. And then I'm going to divide by 5/2 plus c. And instantly we can see we've got all sorts of fractions in here, which makes it look awkward. So this next step is the important one. If we just think about this bit underneath and not worry about this part of it, this 5/2 for now, remember what I was saying. If I'm dividing by a fraction, 5/2, I invert the bottom fraction and it becomes a multiply. So that means this then equals 5/2 times 2/5 x to the 5/2 plus c. So I've taken that 5/2, which was underneath, and inverted it. So the 2 comes up to the top and the 5 goes underneath. They are awkward when you first start to use them, I accept that. Now we can see that actually the 5's cancel and the 2's cancel, leaving 1's. So the whole thing just becomes x to the 5/2 plus c, which I can rewrite as the square root of x to the 5 plus c.